This Power BI dashboard looks impressive. The numbers are correct, filters work smoothly, and everything responds instantly. That's the result of a strong and well-built data model working behind the scenes. But even when a data model looks properly organized, hidden issues can still cause major problems. Let me show you a real example. In this data set, we're working with two fact tables, one for transactions and another for inventory. Both tables include date columns, and we're using a date table as calendar for time-based analysis. However, only the transaction table is connected to the date table. The inventory table has no relationship with the date table, and that creates a serious problem. For example, when we apply a date filter from the 1st of July 2022 to the 31st of July 2022, the filter correctly narrows down the sales data, but it has no impact on the purchase data because the inventory table is not connected with the date table. As a result, Power BI evaluates sales from the transaction table within the selected period, but pulls purchases values from the inventory table without applying the same date filter, calculating them across all dates. This leads to a clear mismatch. That's why the table visual displays 66,170 purchases, while manual check for the selected month shows the actual figure is only 3,869. This overstates inventory valuation and delivers misleading totals, which can lead to inaccurate insights and poor decision-making in the business. To resolve this, we need to connect the date table to the purchase date column in the inventory table as well. Once both fact tables are linked to the same date dimension table, all time-based filters apply consistently, and the calculations become accurate and trustworthy. In this video, we'll build a proper data model from scratch using the data set of a mobile and laptop shop. You'll learn what data modeling is, what the different types of data models are, how to build effective relationships between fact and dimension tables, and some common modeling mistakes to avoid. This is PBX Tips, and today, we'll explore how a solid data model makes everything in Power BI work better. So let's get started. Before we dive into building models, let's first understand why structure in data is so important. Raw data by itself is less meaningful. In data analysis, large volumes of information alone cannot deliver insights. To extract value, data must be structured, organized, and connected. This is achieved through a data model. A data model is a structured representation of data that defines how individual elements relate to one another and the rules that govern those relationships. A well-structured data model is not optional. It is essential. It serves as the blueprint for accurate reporting and reliable decision-making. In Microsoft Power BI, the data model is the foundation upon which all reports and visualizations are built. When designed effectively, it ensures accuracy, improves performance, and enables advanced analysis. Now that we understand why structure matters, let's explore how this is achieved through schemas. Generating business insights often means working through large amounts of data, and it's important that this data is stored and structured meaningfully. With Power BI, you can structure your data using a schema. A schema refers to a structure that defines the organization and relationships of tables within a dataset. It represents the logical framework of how the data is organized and connected. For example, Mobile and Laptop Shop wants to optimize its inventory and rework its sales strategy to sell more laptops and mobiles. But first, it needs to analyze the relevant data. These data sources include customer, product, inventory, and sales information. Mobile and Laptop Shop can use a schema in Power BI to organize and build relationships between these different data sources. This way, the company can generate its required insights. There are three different types of schemas that can be used to organize and structure data: a flat schema, a star schema, and a snowflake schema. Let's review each of these schema types and find out how mobile and laptop shop can use them. To begin, we'll start with the simplest structure, the flat schema. A flat schema is the simplest form of a data model. All attributes or fields related to the business are stored in a single table. Flat schema is one big table without separate dimension tables and is made up of rows and columns. Each column represents an attribute of the data, like date, customer, or product, and each row represents a record, such as a sales transaction. The flat schema has several advantages. It's very easy to retrieve data from, it's less complex to analyze, and it provides a simple way to visualize information. In other words, it's easy, simple, and quick. However, even though it's an easy approach to understand, the flat schema still has a few disadvantages. It leads to data redundancy and inconsistency, so it is more suitable for smaller datasets. And it doesn't support complex datasets, which require more flexibility and detail. To overcome these limitations, Power BI offers a more efficient model, the star schema. A star schema looks just like a star. Everything begins with one table in the middle, the fact table. From there, it connects outward to several dimension tables. And because the layout looks just like a star, that's exactly where the name comes from. The star schema. Think of it this way. The fact table is where all your numbers live. Sales amounts, revenue, or quantities. The dimension tables are like the story behind those numbers. They tell you who the customer was, which product and brand they bought, when the sale happened, what type of discount was given, and even which vendor supplied. Take our mobile and laptop shop. The transaction table, that is fact table, would store every sales transaction. Then, the dimension tables fill in the details: vendors, discount, products, customers, brand, and dates. When you connect them, you get a complete, easy-to-read picture of the business. A star schema offers many strengths over a flat schema. By storing data in separate tables, it reduces duplication, improves query performance. It also provides a clear, logical structure, making the data model much easier to understand. However, the star schema also has limitations. It is less flexible. Once built, it's hard to adjust. Adding or modifying tables can disrupt the whole model. It also struggles with complex relationships, making the structure harder to manage. And finally, there are maintenance challenges. As data grows, keeping everything consistent takes extra effort. But what if your dimensions need even more detail? That's where the snowflake schema comes in.